In software architecture, a business process is a series of human tasks and atomic actions aimed at achieving a desired outcome. The duration of a business process can vary depending on the tasks involved, lasting from seconds to days, weeks, and months. There are two approaches to implementing business processes. One, the decentralized choreography and centralized orchestration. Decentralized choreography is the natural application collaboration pattern of event-driven architecture that allows services or business domain functions to subscribe to event streams or topics without requiring modifications to the upstream processor or to a central orchestration service. This approach promotes loose coupling between services. Because services/functions are triggered when upstream processors publish specific events instead of being directly invoked, and once a processor completes its processing, downstream processors are triggered on the event or events which are caused by the outcome in a change in state. As a result, choreography allows for new services to be added by subscribing to events, and existing services to evolve and change independently of each other. Existing services can publish new types of events, and as long as existing events remain being published and the event contract does not contain breaking changes, other services remain unaffected. This loose coupling minimizes downtime, reduces the need for coordination of development and releases, which in large organizations can become hard to manage, especially when teams have conflicting roadmaps. On the other hand, in a system that is orchestrated, any changes must be made in the central controller, which creates a tight coupled system that is better suited for small implementations. Choreography improves scalability and performance by removing the need for a central orchestrator. Since each service operates independently, services utilize the benefits of event-driven architecture and can handle spikes in workloads more effectively, and are more resilient to changes in demand, throughput, and load. Furthermore, because choreography eliminates the need for a complex orchestration layer, this makes development simpler and more straightforward. Development teams have more autonomy. Developers can focus on building individual services without having to worry about how they will interact with other services or lines of communication and coordination among teams. This can reduce development time and costs and make it easier to maintain and update the system over time. Choreography also allows for better fault tolerance and resilience, because when event-driven services are responsible for handling their own errors and retries, making the system more fault tolerant and resilient. If one service fails, the overall system can continue to operate and other services can continue to function without interruption. However, choreography has its disadvantages, such as less visibility and control, since there is no central service to ensure state transitions are logged. Each service is responsible for its own monitoring and logging. Decentralized logging requires more effort to view the end-to-end picture, making it more challenging to monitor and control the system and process as a whole. This can make it more difficult to identify and troubleshoot issues when they arise. Choreography can also lead to gaps in architecture and domain knowledge, because processes can attach to event streams and create new data flows without modifications or modifying a central source of truth, which can lead to outdated documentation that can make it harder in the long run to make changes and identify issues when they occur. On the other hand, centralized orchestration provides more visibility and control over the system. It allows for more centralized monitoring and logging, making it easier to identify and troubleshoot issues when they arise. Additionally, a central orchestration control service can help ensure that all services are operating in sync with one another, promoting consistency and reducing the risk of unwanted processing flows. However, it can also result in decreased scalability and increased latency due to central control, which may not be desirable depending on requirements and load. Therefore, based on my experience, I recommend a balanced approach using both choreography and orchestration in a serverless system. However, there is no hard or fast rule for what is balanced. The balance depends on the state of the architecture and business domains and bounded contexts. Architecture, including business, application, data, and organization, needs to be consistently reviewed, and over time, changes and adjustments need to be made to both the application and business architecture, i.e. development team structure, business processes, and support models, in order not to go past the point of diminishing returns for whatever model you are going with. In the serverless world, a centralized orchestration service like Amazon Step Functions can be used to orchestrate processing at the micro level within a bounded context. Then, the centralized orchestration controller logic can publish event or completed events to an event stream or topic exposed by your communication middleware. For example, a Kafka topic. We can then use the choreography pattern at the macro level, enabling processes across systems, bounded contexts to subscribe to and consume those events and trigger their processing independently. Using this approach has allowed my teams to maintain the level of observability and monitoring capabilities that we are used to when using centralized orchestration, while still providing the benefits of event-driven architecture and decentralized choreography that allow my teams and business units to deliver independently and decrease time to market. Remember, it's not a question of orchestration or choreography. It's about finding the right balance between the two different patterns. That is key to building a successful system using event-driven and serverless architecture.